So this is a BGP series class of BGP, Border Gateway Protocol, Border Gateway Protocol. One of the routing protocol that is preferred to be between autonomous systems. See, there are some people who use OSPF between autonomous systems. Some uses even EIGRP. But among all this, BGP is the most widely used routing protocol between the autonomous system. Now, what are the reasons? We are going to see what are the reasons that we need to have BGP as a protocol. Number one, this uses TCP for communication between the neighbors. To communicate, it uses TCP. So when it uses TCP, there is a three-way handshake which guarantees security. So our devices are not going to form neighbor with someone which the device do not know. It is going to know the neighbor first and then establish the session. Only then TCP is possible again. You see, TCP, it's connection oriented. If you want to form peering, first of all, the three-way handshake should happen, for which the neighbor should be known already. Only then I can go and do three-way handshake. So BGP knows the neighbor already with whom it's going to form three-way handshake. Once the three-way handshake is successful, it is going to send all those BGP session packets like open, keep alive, open confirm, and so on. Established. So BGP uses the TCP protocol. Now, how BGP knows the neighbor? So after knowing the neighbor, TCP, three-way handshake. Now how BGP knows the neighbor? Like other protocols, BGP don't discover. BGP needs static configuration of neighbor. We have to configure the neighbor statically. They don't dynamically discover any neighbor. No dynamic discovery of neighbor. We have to statically configure neighbors. So in BGP, neighbors are manually configured. No dynamic discovery of neighbor. That is also secure. See, we configure our neighbor. That's more secure than routers dynamically discover someone as neighbor. Dynamically discovering someone as neighbor won't be that good. Sometimes that neighbor may not be a real neighbor, spoof neighbor, fake neighbor. See how OSPF forms neighbor. If no authentication, OSPF will form neighbor with anyone who is in same area ID, same subnet, same timer. You can't stop that. OSPF dynamically discover neighbor. EAGRP dynamically discovered neighbor by sending this hello packets. Can someone say RIP finds neighbor or not? How RIP forms neighbor? Anyone has got an answer? How RIP forms neighbor?
Sending the hello package.
RIP.
Okay.
How RIP forms neighbor? There is no neighbor for RIP. Neighbors are discovered only in EIGRP, OSPF, ISIS. RIP, no discovery of neighbor. There is no neighbor table. Have you seen any time neighbor table in RIP? Not possible. We will not. RIP never forms neighbor. Without knowing who neighbor is, it keeps sending periodically updates. That's what RIP is. Without knowing who neighbor is, it keeps sending updates every 30 seconds. That is RIP. So if neighbor is there, the neighbor will be receiving the update. Likewise, if neighbor is there, I'll be receiving the update from the neighbor. Else, no neighborship. No learning of route. So, BGP, coming back to BGP, forget about those things. Don't forget. Just try to recall the differences between these protocols. RIP, there is no neighbor, but still they learn the route, but keep on sending the routes every 30 seconds. EIGRP learns the route. They don't keep on sending the update. They only send hello packets every 5 seconds. Likewise, OSPF discovers the neighbor by sending hello packets, maintains the neighbor by sending hello packets every 10 seconds. BGP, no discovery of neighbor. It may look like a negative point, but it is not. Routing protocol's job is to give the route. Dynamic discovery is a complementary. That complementary is not there in BGP. Not here in BGP. So, BGP is a very good routing protocol, but the neighbor discovery, BGP never takes responsibility for that. We have to configure neighbor statically, which is secured. Only when we configure neighbor, the router will go and form neighbor with that router. Only when we configure a router as a neighbor, the neighborship is possible. It's not dynamic. That is good. So, BGP uses TCP, BGP, no dynamic discovery of neighbor. In another word, neighbors need to be configured by us. Or manually configured. Next, BGP is very clear in path selection. If you take OSPF, only one metric, cost, calculated based on bandwidth. Only one parameter it will check, bandwidth. So if you want to select a path based on something else, OSPF will never understand. It understands only bandwidth. Using bandwidth, it calculates the cost. OSPF's metric is bandwidth. Like with EIGRP, the composite value, bandwidth and delay. RIP, only hop count. BGP is not like that. In BGP, we have lots of options. We'll use one of the option. We'll go and tune one of the option to make known the policy, to make the BGP to know the policy in path selection that we want. You see, if you want a special path for some destination, whereas for other destinations you want to have another special path. For some destination you want to have some normal path. And for all these three paths, you have different idea, different policy, different metrics to focus. The same protocol can select one path based on X, for some destination based on Y, for some destination based on Z. BGP has got rich metric. That's what I mean. Rich in metric. We call it as attributes. BGP has got attributes, rich in metric. So, depending on our expectation in path selection, for different destination you may have different expectation. In OSPF you cannot have different expectation, only based on bandwidth. It can select path. So your expectation need to be lined up with bandwidth alone. BGP never focuses on bandwidth or delay or anything that is variable. BGP looks for our approval, our configuration in path selection. According to what you approve, what you configure, BGP will follow it. If you say just go like this for that destination, don't go those ways, just take this way. And for other destinations, you just take this way, not the other two ways. Now if you say that, BGP can understand. No other protocol can understand. That's why it is said BGP has got attributes. BGP has got attributes. Like human being has got attributes. Yeah. When we see ice cream, and there are some children around, we don't try to eat first. We give the ice cream to the children first and then we eat. But when there is no children and when you want to have an ice cream, as soon as you see the ice cream, you just don't think about, oh, let me try to find some children, give ice cream to the children first, then we will wait after and then eat. No. Depending on the time, we keep changing our behavior. Our attribute changes. Not the same behavior every time. Sometimes we eat fast, sometimes we eat slow because the others are watching. We eat fast because we need to rush, and we don't care who is watching us because we are using in a restaurant. But with the relatives in home, we focus on the discipline. We eat as slow as possible, which is also good for health. Attributes, meaning selecting the path not based on bandwidth, not based on load or delay, but based on the policy. That's what attribute is. Policy. In front of children and others, relatives, I need to be more disciplined because they should not learn wrong things from me. So I behave in one way. But when I'm in urgent, I need to rush somewhere, my behavior is different. Attributes. The same person, to do the same job, we take different behavior. That's what attribute. Which can be achieved through this protocol. BGP can provide us policy-based path selection. Not simply based on one metric called bandwidth. Rich in metric. BGP has got attributes. As I said, BGP uses TCP, then what layer protocol it should be? It's an application layer protocol. It is an application layer protocol. Application layer protocol.
So that would be layer 7, right?
Correct. Correct. Like TCP, like SSH, like HTTP, and many other protocol. BGP is also an application layer protocol. Fine. If it is an application layer protocol, definitely it has to come down. The packets that are generated, prepared from the application layer, needs to come down to the transport layer. So they need port number. Either TCP or UDP port number is needed for all application layer protocol. See, for Telnet, you have a port number 23. Do we have a port number for OSPF? No. EIGRB? No. Why? They're layer 3 protocol. Network layer protocol. They're layer 3, network layer protocol. They don't need a port number. BGP is an application layer protocol. It uses TCP 179. TCP 179. Okay, so BGP uses TCP 179. That's the number. This never changes. It's an industry standard. 179. See, the administrative distance is changeable. We can change the administrative distance. Even the name is not same for all multi-vendor routers. For Juniper, we don't call it as administrative distance. We call it as preference. Even in Huawei, we call it as preference. In BGP, administrative distance in BGP is 1. No, not 1. Administrative distance in BGP is 200. 20. 2 administrative distance. See, have you come across 2 administrative distance for any routing protocol before?
No, sir.
No, we have. For EIGRP, 90, 170. 90 is for EIGRP's own routes. If you take OSPF route and give it to EIGRP, it is 170. If you take OSPF route or any other protocol route and redistribute into EIGRP, then those routes are external to EIGRP. So they are given less preference. So administrative distance bigger means what? Less preferred. So for the redistributed external routes, you will see EX in the EIGRP routing table. External. D is dual. In the routing table, that's how it will show you. DEX. EX means external. For external, less preference is given by EIGRP. Administrative distance is 170. For internal, meaning BGP's own network, the administrative distance is 90. Because they are native to EIGRP. Fine. Don't forget, EIGRP has got internal 90 as administrative distance, and external 170 as administrative distance. They are not same, internal and external. Right. Now, BGP also has got, okay, one more question again. What is the administrative distance of EIGRP? Can someone say?
$90.
90 is what?
Internal.
Exactly. And the other one?
170 external.
Right. It is opposite in BGP. In BGP also we have 2 variations. One is called as EBGP, external, EBGP, and then IBGP. You see the opposite. Here for I, internal, it's lower, means more trust. External, less trust. Bigger the number, less we prefer. Less importance given. But if we see here in BGP, there are 2 flavors in BGP. EBGP, external border gateway protocol, internal or interior border gateway protocol, interior and exterior, internal or external. IBGP has got 200. EBGP is 20. Now, what is the meaning of EBGP? EBGP, as the word says, external, out of or between, outside this and outside this autonomous, which means between the borders. When we configure BGP, they got a special name to called exterior or external border gateway protocol. External border gateway protocol. So the route learned between the autonomous system, administrative distance is 20. But when I learn from this border router to this router and to this router, when I learn this A network here, they are called as eBGP. But when the same A comes here and here, it's called as iBGP because it is internal to the autonomous system. So BGP has got different name depending on where you configure. When I configure within autonomous system, the administrative distance is 200. So within the autonomous system, I also have OSPF 110. So which one is going to prefer for the local network? For the local network, OSPF will be preferred. Definitely OSPF is not going to bring A because we don't run OSPF outside. A is coming only via BGP. In case if OSPF knows A, OSPF's route A is preferred than BGP learned route A. Yes or no? Yes. Because see the number. The routing protocol prefers the route whose administrative distance is less. 110 is less than 200. So within the organization, if BGP and OSPF have got routes for same destination, OSPF route is going to be preferred, not BGP. That's what we see here. Administrative distance is 200 for iBGP, whereas for OSPF the administrative distance is just 110. Smaller is preferred. Between autonomous systems, which we call as eBGP, even if you run OSPF, see we don't run OSPF, in case if you run OSPF, will the OSPF learned route would be preferred? No. eBGP learned route will be preferred. Because eBGP's administrative distance is just 20. Yep. So iBGP is 200, eBGP is 20. OSPF administrative distance is 110. Within the organization, if OSPF and BGP provides route, OSPF route is preferred. Between the organization, if OSPF and BGP gives a route, BGP is preferred because between the organization, administrative distance is 20. So don't forget, eBGP 20, iBGP 200. Again, these things are not same for every vendor. These numbers are not same for every vendor. Idea is same. What idea? Giving more preference between the organization or between the autonomous system. Each organization is an autonomous system. Between the organization, between the autonomous system, more preference, which is 20 here. Within the organization, it's 200. Please ask me a question if you have on this administrative distance. We'll be having more explanation for eBGP and iBGP after some time. But we are just focusing here on the number. Administrative distance 20 and 200. All right. Now,
so
yes, please.
Based on the administrative distance, that's what the path that will be shorter.
repeat again.
I just wanted to make sure I got it clear that the administrative distance is the path that the packets will choose first. Is that what it is?
Administrative
Or the closest?
Administrative distance is the number given to routing protocol as a preference value. See, you got an apple, you got an orange. And if I ask you which one you want to have, you will say definitely not both. You will say one of it. Because the administrative distance for that fruit is smaller. Repeating again. You need to eat a fruit. That's the destination. And you got two routes. One is orange, one is apple. You can go via orange, you can go via apple to reach the destination. To complete the task eating fruit, you need to eat any one of this. You have to choose any one of this. You cannot mix both and eat orange and apple, not possible. Same way, you cannot use both the paths to reach the destination. Fine. Now OSPF is saying let's go via orange. BGP says let's go via apple. Now router cannot listen to both. It should choose one. It should either choose OSPF, orange, or apple, BGP. Which one it will choose? If it is this router, internal router within the autonomous system, it will choose OSPF, orange. It won't prefer apple. If it is between the autonomous system, it chooses apple, not the orange. Why? 20 is the administrative distance for BGP here, whereas here it is 200. Compared to OSPF 110, 20 is lower, prefer. Whereas here, compared to OSPF is lower. So routers will listen to OSPF. Routers listen to OSPF because OSPF administrative distance is lower. Whereas here, routers listen to BGP because BGP's administrative distance is lower. So whichever the protocol provides route with lower administrative distance is what the preferred one. Is that clear?
Yes, sir. Thank you.
Okay, welcome. So this is not a new topic for us. We are just. So let me quickly, to make it more clear, I want to take another example. Because these things are very basic, we should not go to next topic without making clear. Forget about BGP, OSPF, all those stuff. Let's take one router. For a destination, let's say 1.1.1.1. You have written a static route saying go via this router. Router 1. Go via router 1. You have written a static route here. Static route is saying go via router 1. Next. To reach the same destination, you got another router. That router says, sorry, you got a protocol OSPF that says to reach 1111 you go via router 2. And you got another protocol, EIGRP. So you got static route, you got OSPF, you got EIGRP. Same router runs different protocol for discovering the routes, which is same. Route to reach 1111 is what the route it is discovering. It is what the destination to which we are trying to learn route. So if you see router 3, router 3 has got router 3 is the preferred path given by EIGRP. EIGRP says you go via router 3. So this router, without any confusion, it has to pick one path. It should not okay, I'll come here. The other one saying, come this way. Okay, I'll come there. The other one is saying, no, you come here. Okay, I'll come there. No, not like this. This is not a good behavior. Stick on to any one. To stick on to any one, we need administrative distance. So what happens? For the static route, the dynamically given, the default administrative distance is 1. OSP 110, for EIGRP 90. So what this routing protocol does, it chooses this path. Why? Administrative distance is lower. Always when there is multiple source giving routes for a destination without confusion, the routers will simply pick one path. It is because of this administrative distance. They compare. In case if you don't have a static route, sorry. In case if you don't have a static route, tell me which path it will take. Will it take R3 or R2?
R2. R3, sorry. R3.
Very nice. R3. The reason is, tell me. The reason is?
Administrative distance.
Yeah. Lower is preferred, no?
Lower.
Correct. That's all. You know about the administrative distance very well now. Let's move on to next. So, the administrative distance for eBGP is 20, for iBGP is 200. That's another point that we learn. Next. Why BGP is important? We are learning why BGP is important from the beginning. It uses TCP. Neighbors are manually configured. When neighbors are manually configured, you got control over neighbors. That's a security. Another one, it's rich in metric, meaning you got many metrics. According to your policy, you may choose one of the metric and tune it so that path selection will be as per your policy, not simply based on bandwidth. Path selection as per the policy. Definitely we have a lot of policies between the organization. So this protocol is very important, recommended between the autonomous systems. Next, the application layer protocol. It's an application layer protocol. So it needs a port number. In the transport layer, it uses TCP 179. And then administrative distance is 20 and 200. You know, every routing protocol has got some authentication method to authenticate the neighbor. BGP also uses an authentication method. Before we talk about BGP, we just finished authentication on OSPF. That was our topic 2-3 classes before. OSPF, supports two types of authentication. Is it true or false? Is the statement true? OSPF supports or has got three type of authentication. Is it 3 type or 2 type? 3. Null authentication. Next, clear text, type 1.
Clear text.
And then type 3 is, type 2 is MD5. Type 0, type 1 and type 2. 3 different types of authentication in OSPF. BGP supports only MD5 authentication. You see how much secure it is. You are giving neighbor manually. Not only that, if someone spoofs the neighbor address, I'm saying form neighbor with Sam. But what if someone is simply saying I am Sam, but he is not really Sam? How will I know How will I know he is not real Sam? Authentication. So I'll form neighbor with the neighbor only if message digest the hash value matches. Alright, so BGP uses MD5 authentication, that's why it is more good, secure. Next, to maintain neighbor, what is sent to maintain neighbor in OSPF and in EIGRP? What packet is sent to maintain neighbor?
Hello.
Yes. Likewise, here to maintain neighbor, keep alive packets are sent. What packet? Keep alive. Keep alive packets. This is TCP based protocol. TCP based packets. TCP using packets. Keep alive. How often they are sent? They are sent every minute. Keep alives are sent every minute. Every 1 minute, keep alives are sent. BGP uses keep alives. Keep alive packets are sent every minute. You can say 60 seconds every minute. Alright, next. BGP, because it uses TCP, they keep sending sync packet every now and then. Sync packet. So that is also an added additional security. It will go and try establishing session every now and then to check whether the neighbor is still there. Randomly, every now and then TCP will send SYNAC packets. What is that SYNAC? See, TCP, BGP uses TCP. What does it mean? BGP uses the connection-oriented approach to identify the presence of the neighbor. BGP, before sending any BGP packet, it will first go and see whether the neighbor is ready to talk to me. It will go and check whether the neighbor is ready. For example, you got 2 routers. So this router, when you configure BGP saying, hey router, your neighbor is 172.16.0.2. When you say that, this router A will send. We'll go to this router. Let me put it simply first, then I'll take it to the technical side. A will go to B. B, hi. How are you? I am BGP TCP packet. BGP is TCP packet. Meaning, I'm coming to you in order to check whether you support BGP. That's the meaning. A will go and say to B, it will go to B and say, B, are you B? Yes, I am. I have come here to check whether you also support BGP. Wait. BGP will say, wait. No, I don't support. Why? Because I'm not configured with BGP. See? A only configured with the neighbor address. Where is the neighbor address in B? Not configured, no? So B will say, sorry, no. But, thanks for coming. The thanks for coming is an acknowledgement. You see? There is a SYN packet sent. And there is an acknowledgement packet sent back. Thanks for coming. But B is not sending SYN. Why B is not sending SYN? Because B is not configured to form BGP. B is not interested. So BGP is silent. It simply says, thanks for coming. But it is not saying, I also want to form neighbor with you. It's not saying that. I also form neighbor with you. I also want to check whether you support BGP. It's not saying that. So only when both agree, things will come to pass. Only one is ready, the other one is not ready. Now, if I would have configured on B, neighbor 172.16.0.1, now what would have happened is, when BGP send acknowledgement, it will also send its own SYN packet. Now, when A receives this acknowledgement, A is happy. A knows that B is responding me because he said thanks. But these two are very gentlemen. A will check whether B is also interested. Yes, he is interested. B is also coming and asking, hey, hello, hey. Even I also want to form neighbor with you. And A will now say, thanks for asking. Acknowledgement. This is what called as three-way handshake. If you don't configure this neighbor here, it will not complete the three-way handshake and the neighborship will never come. It will be just two-way handshake. It's not complete TCP. TCP sessions will be established only when three-way handshake is complete. I'm sorry. The three-way handshake should complete. Only after that. Now A knows that B is also interested. B knows that A is also interested. And they both know that they both can talk each other, they understand each other. So now they are ready to send the BGP's first packet called open packet. You see, this approach is not seen in any other routing protocol. Before sending this BGP packet, the very first packet, it should be first of all successful. It should be successful. It should be more successful in forming three-way handshake. It should do three-way handshake successfully. Only then this is possible. Otherwise, no BGP packet will go. You are safe. You see? Safety. You see why BGP is so important between borders. Because of this, between borders, I cannot simply blindly form neighbor with someone. This is one organization, this is another organization. So we need all these diplomatic approach. Hello, I want to form neighbor with you. And this will say, hey, wait, let me check. Sorry, I cannot because I'm not configured. In case if configured, it will say, yeah, I'm also willing to form neighbor with you, along with the acknowledgement. And this says, okay, thank you. And then only starts the neighbor. So this diplomatic approach between the autonomous system is needed. But within the autonomous system, it's not necessary. That's why OSPF, EIGRP, they don't use TCP. But between organization, between autonomous systems, we need this connection-oriented approach. That's why we use TCP protocol called BGP. TCP protocol called BGP. So today we have seen introduction to BGP, and we have seen a lot of important points why BGP is so important. Number one, as the word says, border gateway protocol. This protocol is given high importance in the border sites, between the borders. That's why you see the eBGP administrative distance is 20. High importance. Smaller the number, high importance. The other reason is it's connection oriented, which is more secure. But to establish connection, you have to manually configure the neighbor. No dynamic discovery of neighbor. BGP will not configure neighbor dynamically. You see, to dynamically discover neighbor, what was that needed in EIGRP and in OSPF? Please tell me. Hello packets will be your answer, I know. But what was that hello packet using to discover neighbor in EIGRP and OSPF? What is that OSPF and EIGRP uses was using to form neighbor? Multicast address. Multicast address. A multicast address 224.0.0.10 is for EIGRP. So there is no need for knowing the neighbor. You simply send the hello packet to that multicast address, and the other EIGRP routers are going to listen. Whereas in BGP, we have to configure neighbors manually because no multicast address is used in neighbor discovery. So if someone is asking, what is the multicast address BGP uses? Should not have any confusion. You should say there is no necessity for that. Why? We are manually configuring the neighbor. We are giving the IP address of the neighbor. So to that IP address, the three-way handshake is going to happen and neighbor is discovered. So there is no need for a multicast address. Is that clear?
Yes, sir.
All right.
Sir, I had a question. Just out of curiosity. Since we studied about OSPF using the MD5 authentication, what would be the difference of using BGP and OSPF with the message digest authentication?
Message digest is the same common algorithm. There is no big difference. This is BGP using MD5, that is OSPF using MD5. Yeah? There is no big difference between. See, algorithm is same. Their neighbors are dynamically discovered, and authentication is done with the neighbor which is dynamically discovered. Whereas here, authentication is done only with those neighbor that are configured by us. That's the big difference. Authentication is done only between those routers for the neighbor which we have configured. So,
because OSPF is kind of like a flood, right?
Come again?
OSPF kind of floods the routing.
Yes. OSPF is a kind of flooding the multicast packets to discover neighbor and authenticates neighbor using the same multicast packets. But here it is very precisely configured to authenticate only these neighbors, authenticate only those neighbors that are configured. Right. So BGP has got rich metric called attributes. BGP works on application layer, uses TCP 179. The administrative distance of eBGP is 20, iBGP is 200. The authentication used is MD5. Keepalives are sent every minute. Yeah, and then the three-way handshake which we saw. So in our next class we are going to see the different topology, different type of network design in which BGP suits, where it suits, where BGP is preferred, where it should not be configured, where it should be configured. And those are the things that we are going to focus in our next class. Hope you enjoyed today's class.
Very much, sir. Thank you.
Thank you. See you tomorrow. Thank you. Take care.